So now let us try to look at the second step, how these atoms are occupying this space within the unit and how much voids are available within that particular unit cell. So for that we will look at atomic packing factor, that is APF. How we are going to do that? We will calculate the volume of the atom per unit cell. So we need to know how many atoms are there within that unit and total volume of the unit cell. If we divide these, we'll come to APF value, that is how much volume is occupied by atoms within that particular unit. So for these three, for simple cubic, for BCC and FCC, first we have already established how many atoms are there, 1. How many atoms are there within the unit, 2. How many atoms are there within the unit, 4. So if we multiply the volume of any particular atom, that is simply 4 by 3 pi r cube, 4 by 3 pi r cube, 4 by 3 pi r cube. And at the same time we have to utilize the relation between the dimension of lattice and radius of the atom. For simple cubic we have r is equal to a by 2, that is what we have filled here, a by 2. For BCC we are having r is equal to under root 3 by 4 into a, that is what we have used here. So we can calculate the volume of the atom for BCC. Similarly for FCC we can calculate the volume of atom. So once we know the volume of atoms for simple cubic, BCC, FCC, and we know the number of atoms for all three, we can multiply and we can calculate the volume of atoms in a particular unit cell, right? And the volume of unit will be A by A cube. This is simple cubical volume formula. And once we divide these two, for simple cubic, for BCC, for FCC, we will come to a value, that is numerical value. For simple cubic it is 0.52, for BCC it is 0.68, and for FCC it is 0.74. That means in simple cubic cell atoms are taking up to 52.4% of the space inside that particular unit cell. For BCC it is occupying 68% of the volume. In FCC it is occupying the 74% of the volume. So if you look at these three figures, you can establish that FCC is highly packed, that is austenitic steel. 68% of the space is occupied by the atoms in BCC structure. So if you talk about the iron, the ferritic, the iron atoms are occupying the 68% of the space within that particular unit. For austenitic steels, if you talk about steels, austenitic iron will be having, austenitic steel will be having the FCC structure. That means we can say iron is occupying the 74% of the space within that particular lattice structure. So now we know how these atoms are placed within that unit. We know the radius of those atoms. We know the relationship between radius and lattice dimension, and we now know the space occupied by these atoms within that lattice structure.